All right, so the properties of sums. If I give you the summation of a constant, all you have to do is you take the constant times that upper limit of your summation. All right, so if I give you some constant, so like if I told you for number 1 here, if I told you the summation as I goes from 1 to 7 of 5, you just take 5 times 7. Okay? So that's all number 1's telling me.
Wait, what? Why?
The summation of a constant is just that constant.
But if I was
from 1 to 7.
You do 5 times.
Because think about it like this. Let me pick a small, well, all right. Because if I was going to write this out, this would be, I would do for the 1, but I don't have anything to plug in, right? But you still have to write it for the first one, and then you have to write it for the second one, and you have to write it for the third one, the fourth one, the fifth one, the sixth one, and then the 7th one finally. Well, when you add all those up, that's the same as saying 7 times that amount. Okay? Yeah, because it doesn't have a subscript. It doesn't have anything for you to plug into, so it's constant. Just each time it's going to be 5. So the first term's 5, the second term's 5, the third term's 5, the fourth term's 5, the fifth term's 5, the sixth term's 5, the 7th term's 5.
So
If you add them all up, you still get 35. All right. The second one here tells me if I'm taking the summation of I equals 1 to some n of a constant multiplied by some expression, okay, I can just go ahead and put that constant out to the beginning. So I would pull the constant to the front, take the summation of the n, and then multiply it by the constant. So, for example, for number 2, if I had the summation as I goes from 1 to, I'm going to pick an easy one, 3, of 2x squared, I could rewrite this then as 2 times the summation as I goes from 1 to 3 of x squared. Which means, I don't have to keep doing the 2 every time. So it means it would be 2 times, and then this here would be what I put in parentheses. So I would end up with 1 squared plus 2 squared plus 3 squared. I'm just showing you how this works. So then you get 2 times, and you work that out. What's that? 1 plus 4 plus 9. So it's 2 times 14. So you get 28. It's the same answer if you had done this instead, okay? You could have said, well, then this is going to be equal to 2 times 1 squared plus 2 times 2 squared plus 2 times 3 squared. It just keeps us from having to write that 2 each time. Because if you work this out, you get 2 times 1 plus 2 times 4 plus 2 times 9. So you get 2 plus 8 plus 18, which is equal to 28 as well, okay? Just keeps you from having to write that constant every single time. All right, so 3 tells us if we're taking the summation of 2 variables or 2 things here being added, it's the same as taking the summation of them individually. All right? So if I'm taking the summation of 2 things being added together, then I can take the summation of the first plus the summation of the second.
You did the 5x squared plus the 25. Could you do the
Yes, I could.
squared plus?
And then the 25, I could. All right, and then same thing if we're subtracting here. If I got the summation of 2 things being subtracted, I can do the summation of the first minus the summation of the second one. So, yeah, if we had something like we were doing the summation of 5x squared plus 25, you could have broke this up then as the summation of 5x squared plus the summation of the 25. And, of course, you would have beginning and ending numbers on those, not just the e there, okay?
So I